Hello everyone, thank you for being here to my presentation at 10th IWACP. My name is Abelino Guimarães Neto. Today I'm talking about a study I carried out with Gabriel School, Silvia Helena Bonilla, and Rodrigo Franco Gonçalves, Circular Economy and Ecoefficiency, a graphic model to assess the impact of circular business on the economy and the environment. We have investigated the state of the art of circular economy and eco-efficiency, where the search for change from a linear model to a circular model presents the need to create tools that measure economic and environment results simultaneously, enabling decision-making with equity concerning nature and the economy. First, we have presented a graphic model that morphologically reflects the existing economic models test from a case study of the aluminum cans collection activity. The data has collection on direct production or originating in the circular production or collection of post-consumer cans. We analyzed the production, consumption, and disposal in the city of Santos, in the state of São Paulo, in Brazil. The collection of aluminum cans has a lot of accessible data both in local and on the web, which allowed an easy validation of the construction, where the disposal of this data allows for greater criticality to the design that will be projected by the proposed graphic model after the insertion of market data. The model was called Circularity Degree. Its goal is to graphically project current data and prospects for direct and circular makers, allowing for evolution and the supporting decision making. Its premise is Lavoisier's mass conservation law. In nature, nothing is created, nothing is lost, everything changes. Humanity extracts a scarce natural resource to produce goods and provide services which will be consumed and discarded as soon as there is no longer any value or useful life. The ordinate represents the mass of disposal to the environment. The direct chain will be proportionally related to the possible impacts on nature. As the greater the production, the greater the risks of irregularly discarded items to the environment. The circular chain will have an inversely proportional relationship. As the greater is production, the greater the collection, and the smaller the number of items exposed in nature. On the abscissa, we have the revenue and both direct and circular chains have the same proportionally direct relationship, because the greater the production of which, the greater the revenue in which one. The intersection between the curves as collect circular reference. Its displacement occurs according to the difference between the sale price in the direct chain and the sale price of recycled material in the circular chain. The greater the discrepancy, the smaller is the result of the circular chain. Therefore, the greater the distance between two total financially produced in relation to the direct chain. The smaller the discrepancy, the greater the result in the circular chain. The closer the financial result of the circular chain will be to direct chain. The graphic helps to understand the discrepancy between the values and the quantities already collected, indicating whether this market is favorable or not. To expose the scenarios, direct and circular production data are collected, in addition to the price of the original and recycled products. However, issues of ease or difficulty in collection are of great relevance. In example 1, we have a large amount to be collected. In example 2, you have a market already started, and in example 3, a market that may have reached its potential. In all cases, the higher the recycled price, the between the opportunity to invest in collection. Every result production in the circular chain must be considered eco-efficient, as the discarded unit has already production on financial result in the direct chain and now generates financial value in the circular chain again, in addition to reducing the negative impacts on nature. Application of the circular degree model. The results will be displayed in aluminum, as this material is the raw material generates value to the can. Local direct production represents the production of 696,000 kilos of aluminum. Approximately 97% of the cans disposed of are collected, which represents 675,000 kilos. The price of aluminum in the direct chains is $1.66. The price of aluminum in the circular chain, or price per kilograms recycled, is 92 cents. The total revenue in the direct chain represents $1.15 billion. The revenue in the circular chain represents $0.62 billion. This data, when projected in the model, represents the following figure. Here we can observe that if the total collection took place, the circular chain would reach the approximately value of $0.64 billion. However, with the collection of 97%, research the evaluation of $0.62 million, with the approximately 21,000 kilos to be collected. The maximum revenue to be achieved is just $90,320, or $0.01 million, a paltry amount. Until this moment, we have collected, calculated, and entered the data in the model for each project. We must now analyze the project data. This scenario is unfavorable, as the amount of revenue to be earned is relatively low due to the high market value of aluminum. This quantity to be collected is possibly not easily accessible. That is, there is a market that indicates greater risks than against. Discussion and conclusion. This study fulfills its goal of designing scenarios of direct and circular chains simultaneously, demonstrating a way to analyze the trade-off between economy and environment. It is important to test the circularity degree model in several other cases to measure its relevance as a projecting tool for direct and circular market scenarios. It is interesting to add to the economy efficiency analysis issues show as the reduction in the extraction of bauxite for which can collect. The overlap in value between the economy and the environment is a major trade-off for sustainable development and must be overcome. It is necessary to make decisions with equity regarding economic expansion and environment impacts. There is an enormous symbiosis between economy and the circularity, as the economy as nature as a limit to its expansion and must therefore respect it. Thank you for the opportunity to present our work and to everyone who listened.